Okay. Looks like we have a hard. Replace non-coprime numbers in array. You're given an array of integers. Perform the following steps. Find any two adjacent numbers in nums that are non-coprime. Non-coprime. So coprime means they share a prime number. Non-coprime means they don't share a prime number factor. I think. If no such numbers are found, stop the process. Delete the two numbers and replace them with their least common multiple. Least common multiple. Repeat this process as long as you keep finding two adjacent non-coprime numbers. Return the final modified array. It can be shown that replacing adjacent non-coprime numbers in any arbitrary order will lead to the same result. The test cases are generated such that the values in the final array are less than or equal to 10 to the 8th. Okay. Two values are non-coprime if the greatest common denominator, GCD, I think that's greatest common denominator. Greatest common divisor, yeah, okay. If the greatest common divisor between them is greater than 1. So like 3 and 5, or 3 and, I guess it could be non-prime numbers even, so like 6 is 2 and 3, and like 35, which is 5 and 7, are non-coprime. So they don't have a common divisor besides 1. Right, GCD greatest common divisor. So if there are find any two adjacent numbers that are non-coprime, remove them. Find any two adjacent that are non-coprime. If those are, delete the two numbers and replace them with the least common multiple. So the least common multiple of those numbers would be the numbers with all their primes. No, wouldn't it just be their, it would be their product, I think. Because if they are not coprime, and they don't share any factors besides 1. So yeah, I'm pretty sure it'd be the product of those numbers as the replacement. Okay, so 6, 4, there's a common prime factor of 2. 4, 3, that should be replaced with 12, I think. Oh, wait. Am I thinking of the thing backwards? 6, 4 are non-coprime. Two values are non-coprime if the greatest common divisor is greater than 1. Okay, if they have, okay, yeah, I think I'm thinking backwards. I'm thinking coprime rather than non-coprime. So if they have a greatest common divisor that is greater than 1. So here 6 and 4 has 2. So the least common multiple base would be 12. And then 12 and 3 has a common divisor of 3. So lowest common multiple that is also 12. Same thing with 12 and 2 is still 12. 12 and 7 are not coprime. So the next 7 and 6 aren't non-coprime. 6 and 2 becomes 6. Interesting. Note that there are other ways to obtain the same result in an array. So it could have been something like what other process could, I guess they could have started moving 6 and 2. I think they had to start, they need to combine 6 and 4 before combining 6 and 3. 4 and 3 doesn't work, 3 and 2 doesn't work. Interesting. Okay, example 2. So here 2 and 2, that's coprime, or non-coprime. So that replaces with 2. I think 1 doesn't get replaced at all. I think will 1 stay. These 3 become a 3, these 3, and the 3 becomes another 3. Or becomes replaced. Okay. Okay, I think I understand. Let's see. Is there a quick way to identify prime factors? Pretty long array. Oh. Pretty long array. And numbers are not that big. How long would it take to identify the prime factors of the prime factorization of every thing in your array? I guess it'd probably be finite or constant, maybe. 10 to the 5th. 10 to the 5th is 100,000. 10 to the 6th is 1,000,000. So if there are any ones, they will be ones in the resultant array in the same ordering, but not necessarily the same spot. So for any sequence of non-coprime numbers that are not 1, I wonder, I mean, if the lowest common multiple between two numbers are not their product, then they have to be non-coprime. They have to share some sort of prime factor. I wonder if I can do least common multiple between every two consecutive numbers and check to see if it's not equal to that product. If it isn't equal to that product, then replace it. Least common multiple. Function Python. In Python, the least common multiple of two integers can be calculated using math.lcm, available in 3.9. For earlier versions or custom implementation is desired, the least common multiple can be derived using the greatest common divisor formula. Yeah, LCMAB. Okay, so let's double check that this works. Print LCM of, let's say, 12 and 3. So this should be 12. All right, see how fast this is. So I'm going to assume that the I'm not going to assume, but pretty sure that if two numbers share a common or share a common prime factor, which is basically i.e. they are coprime. Whoops. Share no common prime factors, which means that then the least common multiple, then their least common multiple is their product. Therefore, if their product is not their least common multiple, then they are non-coprime. So basically, yeah. Thus, replace two adjacent numbers if LCM not equal to product. Okay, so answer array for index in range n-1. Since I know that I'm going to be indexing at index and at index plus 1, I need to do one less for the top end of the range, where n is the length of the numbers in the array. If I don't want to use the last number in the I think maybe I want to start with answers nums of 0 as answers nums of 0. And maybe index that goes from 1 to n. I'm thinking using just taking the last value in the answer. Yeah, the last value in the answer. We could also maybe do this in place. Could do this in place. It'd be a little awkward. Yeah, it'd be too awkward too. So value 1 is answer, the last value in answer. Value 2 is nums at this index. And then LCM value is LCM of val1 and val2, and if the LCM value not equal to the product, then answer append, then do the replacement, right? So I needed to pop the last thing in the answer, append this LCM value, else I need to take Yeah. I need to take this value. Take whatever the current value is separately. So answer append the value 2. This seems a little. There's some optimizations I think I can do here, but I think maybe this might work depending on how fast LCM is. We'll see how fast LCM is when I need to optimize that. Oh boy, that's really wrong. It's really, really wrong. Okay. 2009. 2009 is probably LCM of these two, maybe. So this thing definitely combined 23 and 23. Okay, order matters, I think. Actually, what is 829 divisible by 23? 899. It's not. Okay, what's going on here? Okay, let me print the answer each pass. Do 287. Okay, so the first pass 287 and 41 has a. Man, this logic is confusing. Okay, so if they're not the product to the replacement, who they are. So I think these are these don't share a prime factor. And then 41 and 49, I think that multiplies to 2009. Could be wrong. Okay. So correct answer. Oh, wait. So 287 and 41. Okay. This is actually 7 times 41. So these are. There's a common factor, which is 41. So therefore, they replace with 2009. And then same thing here. There's a common factor of 41. 2009. And then this thing probably has some factor that's common. And then 899. 899 is added. So factor. Okay, let's go factorization of 2009. 7741. 899. 2931. Huh. So there is no common factor there. So 899 gets added to the stack. 29 and 31. I wonder. 29, 31. 7, 7, 41. So why isn't 899 appearing in here? 287. These all combine to 209. 2009. 899. Non-Coprime numbers. 23, 23, replace with 23. 2000s. Oh, I see. I can replace 2006-77 with 899. Yeah, okay. 2000, what? 2006-77. Something went wrong. Is that too hard for the AI? What's going on here? $29. Yep, okay. Okay, so the issue is, yeah, okay. If when I do a replacement of a top number onto the stack, I need to do a double check that that doesn't cascade. Yeah, that doesn't do it since we're cascading. Cascading effect of collapses. So I think maybe it should be a while. Yeah. Okay. It should be a while in the loop. So I think it should be while true here. Feel like it should be while true. Breaking when this occurs, when you just append. No, breaking when you don't have anything. Okay, so I think it's actually something like index 1. So answer append the value at the index in the nums array, and then see if you can't combine the top two of the array, of the answer array. More like an answer stack. While LCM, or I don't want to calculate the LCM twice. So I guess I need to do something like LCM value equals LCM of value 1, value answer, top 2 of the answer stack. I need to create a dummy value to make sure the answer stack is 2, so it has 2 values. If LCM value not equal to value 1 times value 2. Answered pops. Answer pen the LCM value. Else break. So keeps on trying to do this until it can't. And I think I need to create a dummy value. I think I need to create answers 1 comma that. Gosh damn it, and then the answer is going to be removing that dummy value as well. Actually, maybe. Yeah, answer needs to remove that dummy value. Alternatively, I can do while there's 2 elements in the array. While answer, the length of answer is greater than 1. Alright, I think that might work. Or it might solve this issue. Value 1 not defined. LCM answer -1, answer -2, which are the last 2 elements of the array. Oh boy, it's going infinite. Shucks. Okay, so what do I do here? It's gone rogue. Timed out. So, is my logic wrong? Yeah, I think so. You could say count 0, count plus equals 1, if count equals 100, break, or just return really. Let's go ahead and print out each time. All right, what's going on? 612. Excellent, excellent. So LCM of 612 should be 12. So the answer, it needs to pop 2 things. Yeah, whoops, it needs to pop 2 things. Okay, maybe that's the issue. Okay. Let's get rid of counts. Get rid of print. Try again. Alright, everything seems to work. That thing's figured out. And hopefully this works. See how slow it is. Pretty darn slow. Okay. Looks like there is kind of an order of magnitude difference between my solution and the faster solutions. Alright, let's really consider if there is something, or what could be better than using LCM here. So you want to compare 2 numbers. Okay, so let me think. So 6, 12, 6, 4 has a common factor of 2. therefore they get combined. And then 6 and 3 has a common factor of 3, and they get combined. And then 6 and 2, they also get combined. And then 7 is when it's unique. But then the issue is, like in this one, like it gets stopped here, and then 899 combines with the 23, combines with the 23. 899, no, sorry, 899 doesn't combine with the 23 at all. But 23, 23, 2006, 20,677 combines, and then there's a new, it's like this thing almost acts as a temporary blockade, but eventually they combine, and then there's some factor here that is shared with this factor here. It's almost like some merging water pools, merging bodies of water. Answer value. Pop, pop. So Okay, so let's look at how fast is LCM function Python. It's generally efficient for calculating the least common multiple of two or more integers. Its form characteristics are as follows. Time complexity, it is going to be log of min of AB. So it is based on greatest common divisor. Okay, is there a GCD function? I assume that if they added an LCM function, they probably added a GCD function. Okay, yep. I wonder if I should just be using the GCD function actually. Greatest common divisor. Replace them with their LCM, finding two adjacent non-coprime. I wonder if I should be using GCD logic instead here, like replace things if the GCD is greater than 1. Okay, let's try that actually. Okay. Hmm. Now, the issue is actually the fact that you eventually need to find the LCM anyways. So what's the point in finding it twice? If finding it once, you can determine whether or not you need to find it at all. I mean, greatest common divisor. I guess the lowest common multiple is the product of times product of them divided by their greatest common divisor, right? Product of them times divided by the greatest common divisor. So, okay. Maybe it is slightly faster. GCD value is GCD of the top two of the stack. If GCD value is greater than 1, then answer pops, and answer appends the multiplication. Fuck. If I pop it, I don't have a track for it anymore. Okay, I think maybe I can just do something like this. Answer at -2 is equal to the product of answer at -1 times answer -2 divided by the GCD value. And then I just pop once. Okay. Float object. How is that a float? Really? Greatest common denominator. Greatest common divisor is not a float. What? Float object cannot be. Oh, it's because I did division like this. I see. Because I did the float division kind of. See if this is any faster. I have my doubts. Slightly faster, I think. It was like 20% before. Not noticeably. So appends the last value. Answer appends the value. Then, well, it can be combined. Try to combine. Yeah, okay, so I think there has to be some sort of recollection of the primes that are involved for for really every spot in the array. So like somehow track the prime factors of every value in the answer array, so that you can merge the numbers. Oh gosh. Is there another way? Is there? It's a stack. Combine things on the stack. Combine the last two elements of the stack. And then somehow you remember things. GCD value. I wonder if I can just actually, what would array at -2 evaluate to for a one-sized array in Python? Is it going to go out of bounds? Index error. I was wondering if it just keeps on looping. Like if it's one size, it just goes back to itself twice. I was just wondering if I can maybe get rid of the condition here. Guess it's probably not that fast or not that slow of a condition check. So you have your answer. Is there a way to avoid checking for certain GCDs? Is this, I mean, I assume it has to be this thing that's kind of slowing it down. I mean, I don't think it's the multiplication, I don't think it's the popping. So, like limiting the number of times this call. So, GCD between two numbers. Every number that add onto the array GCD between two consecutive numbers. There is a non-prime factor. Replace. Okay, so 6, 4 becomes 12, 12, 3 becomes 12, 12, 3 becomes 12, and then 12, 2 becomes 12, 12, 7 doesn't change anything, 7, 6 doesn't change anything. 6, 2 becomes 6. 6, 2 becomes 6 and does another check for 7, 6. I see, I see. Yeah. That's where it's fucking up, or that's where it's being inefficient. It's doing a check that it's previously done. It's exactly the same. So this thing only needs, so if it cascades, it needs to actually be a different value in order for it to cascade. Yeah. So I think what that means is the GCD value is greater than 1. If the GCD value is greater than 1, then if the replacement answer LCM value is going to be answer -1 times answer at -2 divided by GCD value. If the LCM value is equal to the LCM value is equal to answer at -2, then just pop and break the loop, else do the replacement, but keep on doing the loop. I guess answer pops always occurs. So maybe I just could do this. No, I can't. It's not. I would normally try to factor out the answer.pop, but I don't know where. Actually, yeah, I guess I can do this. LCM answer.pop is always going to occur. Yeah, otherwise, this is LCM value. I guess I could do this earlier than that, right? I do answer.pop. Oh boy. LCM value. Break. Okay, I think this might be how I want this set up. Okay, so if there is no change, because the LCM value is the same thing as what was 2 away from the top, then which becomes 1 away from the top after you pop it, after you pop the last thing on the stack, then break. Otherwise, replace the top of the stack with that replacement. Yeah, I think this works. And it should be faster. Okay. I mean, was 170 something before? Okay, okay. So 6, 4, 12, 12, 3, 12, 12, 2, 12, 12, 7, no GCD there. 7, 6, no GCD there. 6, 2, 6. I guess this could have been 7, 2 if the ending here was 7, 2, 6. The 2 becomes a 6, and the 6 still doesn't have, still is being compared to 7. So if there's no change, there's no change. So here, this is slight optimization, or basically small optimization. Break early if already compared, done comparison of those prior values. In this case, it's like answer at -2 and answer at -3 originally. LCM value. Yes, we can probably do something like this here. If GCD value is equal to 1, break. Slightly better indentation. Well, length of answer is greater than 1. Alright, I think this is as good as I'm going to do for now. It's kind of late. But summary, not, well, couldn't get full, couldn't get a very optimized solution, but for the above, the process uses a stack, an answer stack, which does the comparison of the last two values and replaces them with their LCM if their least common divisor is greater than 1 using Python's built-in functions. Note that since it's possible to cascade those replacements, the for loop has a nested while loop. which will continue to try to, which will continue to try to check the last two and replace them. Stopping or breaking when that's not possible. Small optimization to also stop when the replacement doesn't increase the top value. As further checks, as the next check would be the same as a prior check. Okay. Time optimization here. This is going to be O of n log k. Where n is the size of the array and k is the size of values in array. This is because the GCD of AB is calculated with O of log of min of AB. Time complexity. Thus, since we're iterating over the array and doing a bunch of adjacent GCD calls, then overall it would be the number of calls times the cost multiplied by the cost of each call. Space complexity is going to be O of n, O of 1, since no additional space is needed. I'm not taking into account the